Beep. And here we are. So we were talking about this yesterday, and this is where my pen crapped out when we were talking about bases and exponents, yes? And the difference between this, which has how many different parts to the base here. Come in, if needed. Apparently not. How many different parts are there in the base here? No. One. Just the x. How many parts are in the base here? Two. What is the mathematical thing that makes the green one have two parts of the base? Seth?
The 3 and the x are in brackets.
The 3 and the x are in brackets. Brackets group in math. Anytime you see brackets around anything, that is one thing, even if it's got more than one part. Does everybody understand what I mean? Hey, Muscan. Everybody understands, yeah? Even if and you don't need to write this down, x squared plus 7x. If there's brackets around it, that's one thing, okay? And it moves around as a group. If you knew that x equaled 2, then this would be for 18, right? It would be one thing. Everybody's cool, yeah? That's what brackets do. All right, so the next thing, of course, is power, and that's everything. A power is a base and see, I'm yelling there, and an exponent. Okay, we always talk about just the exponent as being the power. It's not. The whole thing is. And you read that as base, whatever the base is, to the nth, whatever the power is, power. So this is 7 to the third. 8 with a 9 up there would be 8 to the 9th. Right? You all know this already. This is grade 9 stuff. You don't need to worry about wasting a lot of time, brain power on this, because you already know it. But there are two special names, and that is squared and cubed. They get special names. Everything else, we read it as to the whatever power. 5th, 6th, 8th. Okay? All right. Now, I am going to turn off the screen, and you are going to fill in this chart carefully. Now, I'm going to do the first one so you know what I'm talking about. Here is, you fill in the blanks. So we have a power here, yes? What's the base?
2.
2. What's the exponent? 4. What does that actually mean? 2 times 2 times 2 times 2, which is not 8. What is it? 16. Is everybody good? Fill in this chart. Go. If, when you get out to the far right, where it says evaluate, if you don't know how to use your calculator to do the big numbers, you can leave that blank if you don't remember. I'm thinking of the 4th row down, right? That's going to be a very big number, and some of you may not remember how to do that on your calculator. But we'll talk about that when the time comes. Cabbages? No one? Lettuce? Cabbages? Never mind. There's the right answers. I've highlighted all those in blue for a reason. There's something I want to talk about with all those blue ones. So check your work. Make sure you have done everything okay. And then ask if you need to ask. So I'm going to let you ask first, and then I'm going to talk about why I highlighted all those in blue. Does everybody remember how to do number 8? How to make your calculator give you the answer? Everybody? And by giving you the answer, I mean you didn't go 8 times 8 times 8 times 8 times 8. You used the exponent button, right? Everybody knows how to use it? Huh? No, somewhere on your calculator, Seth, there will be an X with a Y above it, or a Y with an X above it, or something that looks like this, a little mountain.
You have to turn your phone using mine.
Is he using his phone?
No, I got it.
Oh no, there's an exponent button on there. Somewhere on there, it looks like this, Seth. It's either X with a little Y, Y with a little X. You found it? No, not an E with an X, or this little mountain.
It's probably boxes.
It might be X with a little box above it because they've had to do that because people are so bad at math that they've have to do this. One time, Summer, I've even seen this, blank with a blank above it.
Oh, yeah.
Because people, oh my God, letters in math! Ah! Letters are for reading! But, in today's current climate, I don't even think letters are for reading because nobody actually reads any information. They just see whatever headline somebody posted on their anti-social media, and then that must be true. Right? Because if it's on the internet, it's true. World's flat. Well, it must be. Listen to people talk in the streets.
How come we don't fall off the earth? Because it's flat.
All right. So anyway, did you find the button there, Seth?
No.
Well, we'll talk about it later. We almost never use that button. Don't worry about it, Jake. We'll find it later. It's there. Trust me. I'm going to be like your mom, and I'm going to be like, if I come over there and find it, right? Oh yeah, Summer knows that gag. I can't find any socks, Mom. Did you look?
No, it's fine.
Of course she finds it. Because we look, Summer. We don't go like this. No socks. We move things. Lies. All right.
Years after they go there.
There's an old TV show that has an episode like that. The guy in it is looking for his keys. The show opens. He's looking around. He can't find his keys anywhere. He leaves the room, and then some guy runs out and puts his keys on the desk and runs away. And he comes back in. He says, because the guy that's looking for his keys is living in a TV show. And he doesn't know, like that movie, The Truman Show. But the gag is all of us are living in a simulation.
Yeah.
And there's people doing, and like the guys that made the set forgot to put the keys there, so they run out and put it there. Now, when did that show come out? 1955. They were already thinking of The Matrix in 1955. Anyways, sorry, back to math. It's one of my favorite episodes of that show. All right, here we go. So why is that first one highlighted? Because of this, right? Is there a bracket around the negative? No. So what's the base there? It's only the 3. And the base is what's repeated. 3 times 3 times 3. And 3 times 3 times 3 is 27, yes? But remember, this actually means -1 times 3 cubed. So here is the -1. So -1 times 27 gives me -27. Okay? Oh, I made a mistake there. Shoot. That's supposed to be positive. Sorry, everyone. No, I was in the negative vibe because I was highlighting. And this one, of course, the negative is in the brackets, yes? So it's negative, which gets you a positive.
Yes.
Right? Now, what if I made this 3? What would be here? Another -5. And would this answer be positive or negative? Negative. It would be -125. Everybody cool? Yeah. All right. So, We're good now down to here. -1, because the negative went again and again and again, it's part of the base. Now, since it had an odd exponent, the answer is negative. What if I added another -1 there? Then this would become +1. Right? Everyone's good? Okay. Then we're good down to the next blue one. We should be good down to there. Why did I have to leave this as XXX? Because I don't know the number, which is why I also couldn't evaluate it, could I? You can't tell me what that is because I didn't tell you what X is. And then this one always messes kids up. How do I have positive base and a positive exponent and end up with a negative? I got to have the -1 out front. But this one's weird because if I did -2, oh, there goes my early today. Nice. Nice. Good technology always saves the day. Ooh, it won't even let me close it today. Awesome. Solid.
So, there you go.
If I did -2 to the 5th, would I get the same value? You don't just get to say yes and no and wait. If I change this to this,
It will be the same.
It would be,
No.
it would make it positive.
How? It's an odd number. Positive.
so you guys argue about that for a minute while I try to get my purple dot back.
If it was 4.
Would this, highlighted in green, get me the same value out here? Yes. Why? Because it's an odd exponent, right? But remember, so -2 to the 5th equals -2 to the 5th. They're the same thing when you evaluate them. When you write them out, they're totally different. Does everybody understand that? Spectacular. And then everybody understands why there are 2 9s and 2 ways to get 9? There's a third way to get 9. We could have done 9 to the 1, right? So everyone's good with the rest of them? And everyone's good with this one in particular? The negative repeats 6 times, so it should be positive. But there's a negative out in front, so that wins at the end. Is everybody good with this chart?
Yeah.
Okay. Now, this chart should have been pretty much what you did in the 9th grade, right?
Yes.
Except some of you may not have done that row. But I think I asked yesterday, and everybody did do some work with that in grade 9. So that row is grade 10. We almost never will be using numbers in grade 10. It's almost all going to be variables. Is everybody okay with that? All right. So let's turn the page over to page 13. Now, everything on page 13 you should already know. But I got to make sure, because as I have learned in 22 years of teaching, even though there are only 7 things you need to know about exponents, for some strange reason, it's always poorly done. No matter how I teach it, no matter who teaches it, it's poorly done. Because in grade 11, I get kids from all the other math teachers, and they all stink at exponents. Whether they were taught by me, George, Charlie, Mr. Snickle Fritz, who cares? They all kids stink at exponents. And I don't know why, because there's only 7 things that can happen. And if you write down what is actually going on, it makes perfect sense. So we're going to start real slow with stuff that you already know. So I'm going to multiply powers of the same base. Did I tell you what the base is? No. So what do we give it in math when I don't give you a number? A letter. And kids always say X. All right? So we'll stick with X. X is a base. Everyone agree? Now, you can give me a number for the exponent. Somebody say a number. What? 7's too big. I don't want to write it out that much. It has to be under 4. 2 times x to the 4th. Are they the same base?
Yeah.
Yes, they are the same base. Now, every one of you is going to say, what's the answer? All of you should know this. X to the power of 6, right, Muskan? Why? Yeah, that's where you have to stop. Is it because you add the exponents, or is adding the exponents what you do in this case? Does everybody understand the subtle difference in what I said? Okay. What you do here is you add them, but that's not why it's 6. Adding them is the shortcut. And when you only learn the shortcuts, that's why when I give you a really big exponent question, that's why you guys screw it up. Because you're only learning the shortcuts. You're not learning what's actually happening. Everybody cool? So what is actually happening here is, what is that really? X times x, yes? Times, what is that really?
X times x.
X times x times x times x, right? Multiply, 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 multiply. Have I repeated my multiplication?
Yeah.
So that becomes x to the 6th, right? Trust me, I know it seems stupid to learn it this way when all I need to say is add the exponents. But trust me, this is what you need to know. So then we can come out here and do exactly what Muskan said, because she's absolutely right. X to the a, x to any exponent, times that same base to any other exponent is x to the a plus b. Easy peasy, right? Now, you're in the 10th grade. You learn to add in kindergarten, right? Can you forget in the 10th grade how addition works? No, you can't. Does everything you've learned in math apply to the very next thing you learn in math? You can't forget previous stuff, can you? So let's pretend this was totally new to you, right? Can you forget about it when we get down to number 6 or something? No. So be careful. That's the next thing that causes trouble with exponents. I can, in one question, use all 7 of these. And that's why exponents gets difficult, okay? All the rules apply all the time, okay? All right, so the second one, easy peasy. We're going to use x again. We're going to reverse this. Instead of x squared times x to the 4th, we're going to do x to the 4th divided by x squared. Now, the next problem that you kids have is you don't recognize the different ways this can be written, all right? This is the same as x to the 4th with a slash, and it's the same as x to the 4th over x squared, because this symbol divided by is a fraction, right? Something divided by something. All right? Everybody good? Now, you're smart young people. What is the inverse of multiplying? Dividing. When we multiplied, we added. So what is the inverse of adding? Subtraction. So the shortcut here is subtract, yes? But what is really happening? What does this really mean? What does that mean?
X times x.
4x, yes? X, 4 x's. Over, what does that really mean? X times x. What is x divided by x? No. What is 6 divided by 6? 1. What is 7 divided by 7? 1. So what is x divided by x? 1. So this becomes 1. Now you all want to cross it out because it's canceled. Has it really disappeared? No, that's why I don't like using the word cancel. It's not gone. It's just a 1 now. So this is 1 times x times x times x. Do we write 1 times anything? No. That's why you cross it out. Now, but when you cross it out, it makes you think it's not there anymore. You have to be careful with that. So what's going to happen here? with this x and this x. That's going to be 1 again, right? What's left? 2 x's, which is x squared. Easy peasy lemon squeezy, right? And the rule, if I have x to the a divided by x to the b, I do x to the a minus b. Easy, right? My pen is slowing down, so I am going to risk shutting off OneNote now before it freezes and bringing OneNote back. That'll show you. All right, we're all good, yeah? Okay, so the next one, and we'll keep with 3 and 4, or 4 and 2. Oops, I like doing those black. X to the 4 squared. Now again, you all already know the law. You know what the answer is here. I know you know the answer, but I want you to tell me why. What is the base here? This is tricky. X to the power of 4 is the base, isn't it? And how many times does that base repeat? Twice. So this really means x to the 4th. Oh, it froze anyway! Son of a... Every good thing I said about that. There. Because it was awesome. That's the best I've ever done that. Now nobody will know.
Is it snowing or is it raining?
It's heavy rain with the sun shining through it. It's not snowing. It's 8 degrees out there. Water doesn't freeze till 0. Grrr! All right, now, ladies and gentlemen, you're going to notice that every law now, from here on, I'm going to stop you along the way, and I'm going to remind you that all the previous laws still apply. All right? So, if I gave you this, x squared, y cubed, squared, how many ways could you, and I don't want you to write down all the ways, but how many ways could we write this down? Can somebody tell me one way I could write this differently than what I've done here and still have the same value? Seth.
X times X times Y times Y.
I could have gone x, x, y, 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 and squared, yes?
Yes.
Okay, what could I do with that? I could write it again because it's squared, right? So I could write x, x, y, 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 x, x, y, y, y. Now, how many x's do I have? 4. And how many y's do I have? 6. Frozen. Oh, but this one, maybe it'll work because it flicked out. Yeah, buddy. Now, that's what's actually happening, yes? But does exponent law 3 apply here? Look back to exponent law 3.
Yes.
When I'm going over a bracket, what did I do in exponent law 3? Multiplied. So isn't this x 2 times 2, x to the 4th? And isn't 2 times 3x y to the 6th?
Yes.
So we're good, yeah? Now, there is one thing that you all screw up here. If I give you this, and I'm going to blame, I wonder if it's this stupid purple circle that's causing me trouble. Anyway, if I gave you this, 2x squared y squared squared, what would that answer be? Remember, all your math applies. And you don't need to write down the work. You could just write down the answer if you can get it in your head. That's cool too. But bear in mind, I wrote this one down because this is one kids screw up all the time. Anybody want to risk an answer? What is it, Seth?
Is it like 2 times x to the 4 times y to the 4?
So close. And that's the mistake kids make. Every kid remembers to do that, but isn't that 2 part of the base?
Yeah.
So shouldn't that 2 also get squared? So it is 4x squared y squared. Kids always forget that in the 10th grade. Okay? Muskan.
What if we left it as 2 squared?
I'm just getting to that now. Some kids will write 2 squared x squared y squared, right? Muskan, I owe you $4, but I owe JJ 2 squared dollars. Which one's easier? 4. Always, if you can, evaluate. Does everybody understand? Would I dock marks here? Do you think? If the question were out of 4, do you think I would give you 4 out of 4? Remember, you guys were all in elementary school. 4 meant you were exceeding expectations, yes? Now, that's a stupid way to measure math, right? Because to exceed expectations in math, what is the expectation in math? To get the answer, right? 3 plus 4 equals 7. Can you get a 4? Can you exceed my expectations when I ask you to add? No, of course not. It's impossible. But because the education system lumps everything together and refuses to understand that math and science are different than socials and English, we are forced to adopt this stupid policy of exceeding my expectations. You can't exceed expectations in math. You can get the answer right or not. So technically, is it possible to get a 4 in math? Is it possible? No. Do I make it possible? Yes. If the answer is absolutely perfect, you have done every mathematical thing you can do, I will give you 4 out of 4. Does everybody understand? So, would this be 4 out of 4? No, because you can do something. You could make the 2 squared that. This is 4 out of 4. This is 3.5. Does everybody understand? And I'm sorry, but I've heard rumors that that is the way it is going. You may very well be assessed in math by the time you leave high school on that 1, 2, 3, 4 scale, which in math is idiotic. But nobody asks math teachers. Why would we ask the experts? Right? Kind of like how Fraser Health knows who you guys are close contacts with in class all day. Right? Because I got a Fraser Health person standing right here, don't I? Yeah. Who's checking who's sitting where, right? Who does actually know? Who knows who you guys are in close contact with all day right now? You and me. Do I get told if one of you gets, or one person from your family tests positive? No. But that's a social studies question, not a math question. Okay. A fraction base. We all know fractions scare us, but they don't need to. X over y squared. Now, is this anything to be frightened about? Because isn't multiplying pretty closely related to dividing? And aren't fractions just dividing? And what did we do when we had multiple different bases in there and they were multiplied? We just put the 2 to everything, yes? So what do you think we do here? Right. That would be x over y times x over y, which would be x squared over y squared. The 2 goes everywhere. Do all the other rules still apply? Yes or no? Yes. So what if I gave you this? 2x cubed y squared over xy squared. Does that talk about all 6 laws right now? Are they all in there? Is there some dividing? Is there some multiplying? Is there some exponents to multiple bases? Right, so everything's there. Is there a right or wrong way to attack it? No, you just apply the laws in the order you see fit, right? So somebody tell me what would you do first? Muscan? Only because I couldn't hear you, Summer. Because you said add the exponents, then you changed your mind and said something different. I'm not being mean. Muscan, what would you do?
I would solve this out of the box.
So you would go inside here, right? Okay, so now that Muscan has forced us into a path, somebody take over from her. It's like tag wrestling. Muscan's out, somebody just hit her with a chair, and she's reaching to tag at the ropes, and she's tagging in Seth. Seth, what would you do now that Muscan has started down this path?
You have to cancel out the X and Y.
You would deal with this and this, right?
Yeah.
So you would get 2, what would you do with x3 and x1?
Get rid of the bottom one.
You'd get rid of the bottom one, and what would that become?
2.
2. So now I have x squared. What would happen here?
Y. Oh, you get rid of the bottom Y and then change the top one just to normal Y.
To a 1, which we don't write.
Yes.
And now all of that is squared. Now Seth has been hit with a chair, but Muscan, because wrestling is real, has shaken off being hit with a chair, and she's ready on the side to tag in and save Seth, who just got hit with a chair. What would we do now?
You would just multiply the units and everything, so it would be 4 x to the power 4 and then y.
Yeah? Excellent. Now, everybody agrees that's the right answer, yeah? Now, watch. See if I can erase this without killing. Screw it. 2x squared y, or x cubed y squared over xy squared, right? Could I bring this 2 to everything now? Which would get me 4x6 y4 over x squared y squared. Cancel 2 of those. That becomes 4. Cancel 2 of those. That becomes 2. Do I get the same answer? Does it matter which place I started? No. Does everybody understand? That's why teaching exponents is difficult. There's no one path you can follow. Everybody, you can take a different route, and all of you may take a different route, which is the second thing I need to say. That's why showing your work is so important. Everybody cool? All right. That should be good. Everybody should know all of that from the 9th grade. Was any of that news? Excellent. But it's nice to get the refresher. Let's talk about negative exponents. Did anybody do that in grade 9? 1, 2? You did it a bit? Okay. So, remember how I said that knowing the exponent of 0 was what would make you understand this? Right? Let's go back to that. So we had 3 cubed, which equaled 27. I'm not going to bother with the 3, 3, 3. Everybody's cool, right? 3 squared became 9. And I'm dividing by 3 as I go down, right? 3 to the 1 was 3. 3 to the 0 was 1. Now, 4 times in a row, when I drop my exponent by 1, I divide by 3, yes? So what is the next logical exponent? Negative 1. Now we're going to stop for a second. If we were writing that middle column that had the repeated multiplication, is there any way you can imagine writing 3 times itself negative 1 times? Could we write that in any way? No, we couldn't, could we? How would you write that? The last time that we couldn't write something was 3 to the 0, yeah? So what did we do? We followed our pattern. Divide by 3, divide by 3, divide by 3. So we can't write it. So what do we write here? We divide by 3. What is it? 1/3. Please notice it is still positive. Right? Now, What is the next logical exponent? What do I do here logically? Because I can't write the middle column. I got to divide this by 3, yeah? Which would be the same as multiplying it by 1/3, which would be 1/9, yes? What would the next one be? 1/27. Now please look. 3 to the positive 3, 27. How should we really write 27, but we're too lazy to write it that way? What? 27 over 1, right? And look here. What do you see? What do you call this when you flip them? Somebody said it yesterday. Reciprocals, right? So, x to the negative a equals 1 over x to the positive a. And my screen just froze. Maybe we're back. Nope.
I like that you think I was actually going to be able to hear that. I was listening specially. But please notice the color of my hair. I am very, very old. The ears are one of the first things to go.
All right. Is everybody cool?
Yeah.
Now, please notice it's still positive. All right? Now, the next thing requires you to make a leap of understanding. Okay? So, let's do this. X to the 4th divided by x to the 6th. According to law number 2, what should you do there? Subtract. So what would this answer be? X to the negative 2. Do negative exponents exist? Do they make any sense? No, we're never allowed to have a negative exponent. So this is technically x over 1, right? So what is this answer really? How do I write it properly? We just did it right there. 1 over x squared. Is everybody cool? Now, I want to show you something. This means x to the 4th over x to the 6th, yes? Which means x over x, right? What do we do to 4 of those x's? Cancel them out, and they've all become 1s, yes? So what's left on the top? 1, because it's 1 times 1 times 1 times 1 times 1, which is 1, over what's left on the bottom? X squared. See? Does everybody see how this comes together? All right, Muskan.
When we do a test or whatever,
Yep.
would we have to show how we did it? So would we have to do
I'm going to do a couple of questions that use all the laws in a second, and I'm going to show you the way, a way to do it, like we've been doing it all the way along, okay? Now, here's the next problem. Every one of you understands that, right? I've asked 4 times, everybody's nodded, you're all like, yeah, I got it. But then I do this. What is 1 over x to the negative 3? Danny? Pardon? Yep. X cubed. It just reciprocates. Because negative exponents are never allowed. If they're already in the denominator, they would move, they would reciprocate. Is everybody good? Yeah? Yeah, but you got to be careful doing that too, and you'll see why, right? Okay. So I'm going to slide off to the side like I've been doing. If you want to find some white space or some blank paper of your own to practice these, that's cool. But I personally believe that the most important thing you need to do right now is not try to copy down what I'm doing. Try to think through what you would do. Okay? That's why I say don't write this next thing down. There's tons of practice coming up that is written down in your book. All right? So let's try. 5x cubed y squared times 3x squared y cubed squared. More than one way to start this. But this one's really tricky because there actually is only one way to start this. But then after that, there's lots of things you could do. What do you think you need to do first? Seth?
It's on the right.
You got to get rid of this one. Does that apply to orange, purple, or both? Just orange. Right? So the purple one's not going to change. 5x cubed y squared. What does the orange one become? 6?
X.
3 squared is 6. I told you someone would do it.
No, 9.
9. X
4.
to the 4. Y to the
9.
6. Now what?
Now you combine the two.
Combine the two. So what am I going to do with that and that? Add?
Multiply.
Multiply. It's 5 times 9, isn't it?
Yes.
So what is it?
Yes.
45. X what?
Yeah.
7. Y what? 8. Now, was any of that math difficult math? No, of course not. How many of you said the wrong thing at least once? See what I mean? The math isn't hard, right? You can't tell me the math is difficult, but putting it all together becomes problematic, right? When I asked what 5 and 9 was, if I just wrote 5, 9, all of you would say, it's 45, you multiply it. But because we're talking about exponents, some of you said add, right? That's what I mean. Can you forget the 7th grade where you learned that if you write two numbers right beside each other, it's times? Can you forget that? No, that's previous math. And does all previous math apply?
Yes.
Right? Everybody good? All right, let's make a small change to this question. Not that. That's too big a change. We're going to erase all this. Look at how slow it's erasing. This is a PC.
Like a big one.
Hard to get touchscreen.
Connected to those.
All right. Now, I'm going to make a very small change. -2. Now, there's a ton of different ways you could start this. Would anybody like to say what they would do first? Yes, you did start the last one, Seth. Smart move to always volunteer on the first one because you know it's always the easiest. Muskan, what would you do first? And you've been the first one in the ring a few times, so way to go.
I would start the same thing that we did.
So you would deal with that 2 first.
Yeah.
Okay, so you would have 5x cubed y squared 9x to the what?
0.
No. Danny? What? 4? Negative 4, because you multiply over here, yes? And y to the 4. Then what would you do? Combine the two, so it would be 45, x to the what? Negative 1, right? Y to the 6th. Is that allowed? So how would you finish this off? 45. Where would this go? Denominator, because you reciprocate it. X, y to the 6th. Is everybody cool? Now, could you do this a different way? Could you have moved this 2 right away down here? And then this would have been down here, right? X to the 4th. And then everything else would have been the same. I would have had 3 x's in the numerator, right there, 4 in the denominator, canceled them, and left me with 1 x down there. Is everybody good? Please notice how many different ways you can do these questions. You have to decide the way you would do it, right? Now, do you think I follow the same path every time? Of course not. Because let me give you an example again, and you don't need to write this one down either. What if I had 3x cubed y to the 6th over 6x to the 9th y to the 12th, all of that to the negative 2? What is something you could do? Pardon me? You could do inside right now, couldn't you? And that would get you 1 over 2, 3/6, 1/2. 3 and 9. If there's 3 up top and there's 9 down below, I can get rid of those 3, and I can get rid of how many of these? 3. So that would be x to the what? 6th. And if there's 6 up there and 12 down there, I can get rid of those 6. What's down here? 6. Now all of that is to what power? Negative 2, because I didn't touch that one yet, right? Now, what? Stop it. What does it now? Again, could I bring that negative exponent everywhere inside? Could I? But that would mean I would have 1, 2, 3, 4 negative exponents. Is that a pain? It is. But doesn't a negative exponent reciprocate its base? So couldn't I write this as, if I could write, through this? Couldn't I reciprocate that base?
Yes.
So I would get 2x to the 6th, y to the 6th over 1, yes? And all of that would be to what exponent? Positive 2. Now it's super easy, isn't it?
Yes.
What's 2 squared? 4. What's x to the 6th squared? No. 12. Right? Because it's 6 times 2. And y to the 12th. Does everybody understand?
Yes.
Now watch. Right here, could I not also have done 1 to the negative 2, 2 to the negative 2, x to the negative 12, and y to the negative 12? Could I have done that? And then all these negative exponents have to switch, don't they? So this 2 would come up and become 2 to the 2, x to the 12, y to the 12, over 1 to the 2. Do we ever write 1 as a denominator? No. And 2 squared is 4. And you see, you get the same answer. Does it matter what directions you go?
No.
No. Do you have to apply everything?
Yes.
Yes. Is everybody ready to try? Yeah, you are. The first work you do is super easy. 35 questions. They're all you can do in your head. Page 15, and there's like there's 6 questions on page 16. 15 minutes. Go. We'll mark it in 15. Not for marks. You'll just see it if you're doing it right or not. Okay? Go. While I try to get my piece of crap machine working. Okay, the next thing to try might be this pen. You don't need to show your work on this page because it's all in your head, right? Yeah, feel free to close those all the time, ladies and gentlemen. That is totally up to you.
Let me just